All right, in this last video for lesson 10, we're going to talk about another kind of compound probability, and this is when we want one thing or another to happen. And so this is done with or. Or events are going to use what's called the general addition rule. So the probability that A happens or B happens, we're going to add the two probabilities, and then we have to subtract the probability of A and B. And we'll explain why. Two events are mutually exclusive if they can't happen at the same time. And that's frequently the case. And when that happens, this probability of A and B is 0 because A and B can't happen at the same time. And so this will simplify into something that is more intuitive. But I want you to always just use this formula. And if they're mutually exclusive and this simplifies to 0, that's okay. So let's talk about mutually exclusive again a little bit more. You're going to draw one card from the deck. What's the probability? It's either an ace or it's a 2. So keyword is or. Or tells us we're going to do or. First, let's just talk about this idea of mutually exclusive. So here's our deck of cards represented with a Venn diagram. We've got aces. There's 4 aces in the deck. We've got 2s. There's 4 2s in the deck. And there's no overlap between this group and this group, or this event that we're doing and this event that we're doing. There's no overlap, so they are mutually exclusive. You can't get, in your one draw of a card, it can't be an ace and a 2 at the same time. It's going to be one or the other or something else. So mutually exclusive means no overlap of event outcomes. So with the math, we could do the probability of an ace or a 2. I'm going to take the probability it's an ace plus the probability it's a 2 and minus the probability that it's both. So there's our probability of an ace, there's our probability of a 2, and the probability that the card is both an ace and a 2 at the same time is just 0. So we just add those things up and subtract 0. You get 8 out of 52 or 2 out of 13. So whenever events are mutually exclusive, means there's no overlap between outcomes, and it means this and part will be 0. So give these a shot. These are all mutually exclusive events, I'm telling you. So probably pause the video, try them out. Just quickly, this is a queen, this is jack of diamonds, and this is ace. All right, let's talk about solutions. Each one of these, we're going to split the or into a plus. So the probability it's a 3 or a q is the probability it's a 3 plus the probability it's a queen minus the probability it's a 3 and a queen. So there's the probability to draw 3, the probability to draw a queen, the probability that it's both a 3 and a queen at the same time, which is 0 because they're mutually exclusive. And we just add them together. Ace or jack of diamonds. It can't be an ace and a jack of diamonds, at the same time. So we got the probability it's an ace plus the probability of jack of diamonds minus the probability of ace and jack of diamonds. So there's your ace, there's your jack of diamonds, and there's this joint and probability, which is 0 in this case. Okay, so you add them and you're done. Probability of an even or a face card is the probability of an even card plus the probability of a face card plus the probability that it's an even and a face card. So even numbers, there's 2, 4, 6, 8, 10. That's 5 times 4 is 20. And face cards, there's jack, queen, king times 4 is 12. And a card, there's no cards that are an even number and a face card at the same time. They're mutually exclusive, so that's a 0. You add those up and get the answer. Okay, let's talk about the other case. You're going to draw the one card and you want to know about the probability that it's an ace or a spade. Are the events mutually exclusive? Consider the diagram aces and spades. So there's 4 aces. One of them is the ace of spades, and there's a bunch of spades. And so there's this overlapping part. This is actually the and part. If we wanted to find the probability of that it's an ace and a spade, we're calculating this. But anyways, these are not mutually exclusive because there's overlap. If we consider the outcomes in our event, there's an outcome, and there could be more, but in this case there's just one, that are in both events. So what's going to happen if we were just to find one probability and find the other and add them, we're basically going to add this twice, which is bad. But that's why the rule subtracts it. It subtracts one of the extra copies of the number. So let's see how that plays out. Probability to get an ace or a spade is the probability to get an ace plus the probability to get a spade minus the probability that it's an ace and a spade. Okay, so this is 4 out of 52, this is 13 out of 52, and this is 1 out of 52. But what's really going on here is the ace of spades is counted here in this, and the ace of spades is also counted here in this. And so this minusing subtracts out one of the duplicate countings. Anyways, there you have the answer. Give these a shot. Pause the video. This is queen, diamonds, queen, not spades, face card or not a king. Okay, let's talk about solutions. We're just going to expand this with the rule. So or becomes plus, and then we minus the and of the two events. So probability of queen plus the probability of diamond minus the probability of queen and diamonds. So there's the queens, there's the diamonds, there's the queen of diamonds essentially. And once again, the queen of diamonds is in both of these events. So it's being counted here, and it's being counted here, and it's being subtracted once here. Queen or not spade, we have probability of queen plus the probability of not spade, which minus the probability of queen and not spade. It's kind of getting weird. But there's your probability of queens, there's your probability of not spades. That's 13 times 3, or 52 minus 13. And then there's 3 cards that are a queen and not spades. There's the queen of hearts, the queen of diamonds, and the queen of clubs. So those 3 queens got counted here and here. So we're minusing out one duplicate copy. One more example, face card or not king. Probability of face plus the probability of not king minus the probability of face and not king. So there's your face cards, there's your not kings, and there's your face cards that are not kings. That would be the jack and the queen times 4 suits. So if you think about this one, face cards or not king, almost every card's not a king. There's 48 cards in the deck that are not a king. So if we don't minus this out, we'd actually get 60 over 52 because we're counting things twice. So anyways, the proper math is to find each probability, add them up, and subtract the probability of both events with considering the and. And this is a weird one, but we get 52 out of 52, which is a 100% chance that this is going to happen. We're either going to get a face card or not a king card, because that represents the entire sample space. Okay, that is it for this video and this lesson.